This is video number 2 on Le Chatelier's principle. We're going to deal with heat changes today. On our previous video, we talked about stress number 1, which was adding or removing one chemical by changing concentration, and how that affected a reaction at equilibrium. Today, we're going to be talking about adding or removing heat, which is Le Chatelier's principle, the second stress that we'll talk about. So if you have not watched the first video, or you were not here in class yesterday, make sure you go and watch that video first, or you won't understand what's going on here. So adding or removing heat, let's talk about what's going to happen here. Okay, so we have an example here of a chemical reaction, and before we jump into the problem, let's analyze this guy. So we have carbon solid reacting with oxygen to form carbon dioxide gas. We again have that double arrow there, and so that double arrow is going to indicate this reaction is equilibrium. So as we said previously, we can do a couple things to change this equilibrium to cause it to shift to the right or to the left. We can add or remove CO2. We could add or remove oxygen. We could add or remove carbon, and that could change our equilibrium position by shifting one way or another. What we're going to do today is we're going to add heat. Now, they give us a measurement of delta H down here, and delta H, remember, is enthalpy, which is heat at a constant pressure. And the real key to this is it gives me a negative value right there. So if we see a negative value, that tells us this is an exothermic reaction. Anytime we have that negative value, it's an exothermic reaction, meaning that heat will be placed on the product side. That heat's going to be placed right there. Now, once that heat is there, we're going to treat that heat just like it is another chemical. So if we were to add heat to this reaction, they're telling us here that this reaction is being heated, we're adding heat. So it's just like if we were to add CO2. If we added CO2, this reaction would shift to the left. Well, if we add heat, it's on the right, the reaction is going to shift left. We just treat it like it's another reactant. So we predicted the shift. Down here, the problem says predict the shift, so that it's going to be a left shift. And then the change in concentration for all the chemical species. So for the carbon, we're going to have an increase. For the oxygen, also an increase. And then for the CO2, we are going to have a decrease based on what we talked about yesterday in prediction of shifts. Let's take a look at our next problem here. It says the following reaction is heated. We have N2 plus O2 yields 2NO. And we have a delta H value. Now, our delta H value here is going to be a positive value. Anytime we have a positive value, that means it's endothermic. And so we're going to place the heat on the left-hand side. And we could actually place the number value, the numerical value of 180.5 kilojoules there, or we could just write the word heat. They're expressed both ways. Now, again, this reaction is going to be heated. And so we're going to treat heat over here on the products, or the reactant side rather, just like it's another reactant. So this is going to cause this reaction to shift to the right. And once we shift to the right, then we can predict all of our concentrations. The N2, the O2, and the NO. And remember, this was a right shift. And so this is going to increase the NO. It's going to decrease the oxygen. It's going to decrease the N2. Okay. Last one, we have a reaction that's thrown at us in a slightly different way. They didn't give us the delta H value. They went ahead and put the heat right there, and that's okay. That's fine. Not a big deal. We'll leave the heat there, and they've done the work for us, and we'll just treat it as we normally would treat it. So, telling us an important consideration that this reaction is being cooled, which is essentially we are removing heat. And so think of it this way. If we were to add PCl5, we all know this reaction would go to the left. If we were to remove PCl5, we know this reaction would go to the right. Fair enough. Now, if we were to add heat, the reaction would go to the left, but we're not. We're removing heat in this reaction. So if we're removing heat, it's just like removing PCl5. This reaction is going to shift to the right. It's going to shift towards what you remove. So the changes in concentration in PCl3 and Cl2 are going to be the same. They're both going to decrease because this is a right shift, and the PCl5 concentration, that is going to increase. And that's our talk today on Le Chatelier's principle, heat changes. Remember, just treat heat like it's another reactant or a product if it's exothermic, a reactant if it's endothermic, and just treat it like you were changing chemical concentrations, and you'll be fine for Le Chatelier's principle. Stress number 2. Next video, we'll deal with stress number 3, which is going to be pressure changes.